So hello everybody, we're back for part 3 of this series of graphing videos so that we can review this topic. We're going to focus on standard form right now. So again, if you're looking at the graphing quadratic functions assignment, we'll be using those exercises to work through. We covered vertex form and factored form, or intercept form you could call it, in the last 2 videos. This time we'll be working on standard form. These are 3 things that you want to kind of have mastered by the time we move into the new unit, because things are going to get more complicated and we're going to start working with more complex numbers and more complex ideas, and as opposed to just drawing the graph and me making sure that you guys know how to read these forms, which is really what I'm looking for here. We're going to get into more complicated calculations, so if we have an idea of what we're looking for, it's going to be easier for you to find your mistakes. So please, pay attention, ask questions. This would be the last video in this series of how to graph, and at the end of this video we'll try to tie everything together from these 3 videos and make sure that we have the big ideas and how to not get them confused with each other. So we see that in this case we're looking at standard form, and standard form is different than the other 2 forms. Again, we covered vertex form. Vertex form was helpful because when we look at it, we can basically see the coordinates of the vertex of the parabola by looking at the numbers that appear in the equation. When we looked at intercept form, we saw that that one was interesting because it tells us where the graph crosses the x-axis, but it doesn't tell us the vertex, so we did have to do a little bit of work to be able to graph it. Now we're looking at standard form, and this form, you might notice that this form has no parentheses in this expression over here, right? Vertex form has 1 set of parentheses, whereas intercept form has 2 sets of parentheses. So I've been trying to think of a way to make sure that we didn't really confuse the process, and that's when I realized that if it has 1 set of parentheses, then we change the 1 number in the parentheses. And when it has 2 sets of parentheses, we change the sign of both the numbers that are in the parentheses. In this case, when it doesn't have a set of parentheses, then we are not going to change a number. And the number that is this constant value, and that is the y-intercept. That is the one thing that we can tell just by looking at a standard form equation. Look at this constant value, okay? This is the number that we're not going to have to change, and that tells us the y-intercept. We notice that in our intercept form, A and B were the x-intercepts. So we don't want to get these confused. As we learn how to graph and get better at this, we'll understand more about why this works, and I think we'll talk about this in this video, why this number doesn't change sign, but these other ones do. But the main idea is that we want to know how to read these forms, how to work with them, and kind of develop some kind of instincts. So let's break down everything that I wanted to have in these blanks right here. So let me get these lines away so that they don't distract us. So when we look down here and we say A is the coefficient of the quadratic term. So when we're referring to A in any of the equations that we do down below, we want to say that A is that number that we see in front of x squared right there. So we'll call that the coefficient of the quadratic term. We will consider B to be the coefficient of the, well, if this is a quadratic term, what do we call this term? We call that the linear term, right? This is like a 2nd degree term, and so like I said, 2nd degree, we have this word quadratic. This is 1st degree, and a 1st degree variable basically means linear. And so that's where that comes from. The last thing that we want to make sure we understand is that C, this number right here, is the constants term. And we call it a constant term because it doesn't have a variable. So notice that's the whole definition of variable. Variable means that it changes. So now we should be able to understand a little bit of the vocabulary that I'm using. This still might be a little confusing, but we'll deal with it. Okay, and we want to understand that when we see the constant term, when we're looking at any standard form equation, okay, this value is our y-intercept, okay? It does kind of remind me of the y equals mx plus b. When we looked at that form, we knew that b was our y-intercept because that's what we got when we plugged in 0 for x, right? And so that means that when we look at our graph, you know, and we say, okay, when x is equal to 0, that means we're on the y-axis, and so we knew that we'd be at a value of b. So hopefully that's something you remember, but if not, we're going to be graphing things that are more complicated than lines. So let's break all of this down and understand we have a formula here also that helps us figure out the axis of symmetry. Okay, for now, we're not investigating why this is true. Why is it true that the axis of symmetry is at negative b over 2a? And why is it true that the vertex is going to be on the axis of symmetry with this formula? Well, obviously, we've seen that before, that the vertex of a parabola is on the axis of symmetry. So we could see why this value and this value are the same. And now hopefully from that last example we can see why if I want to get the y-coordinate of the vertex, I'll have to plug in this into my function to figure out the y-coordinate. And then I could plot the vertex and be done. So let's go investigate what I meant by this. And like I said, we're going to start with the most basic idea that you should be able to look at the standard form and tell what the y-intercept is just by looking at it. So we're going to work on that instinct right now. Again, we're saying the y-intercept, not the x-intercept. So as we take a look at this here, we should see where our graph is crossing the y-axis. Okay, and I see that our graph is crossing right here at negative 6. So that means the constant term I'm looking for is negative 6. I also see that this graph is open downward. As we've been saying, this is a sad face parabola, right? And so that means I'm looking for a negative to be the first leading coefficient. So that tells me I'm looking for one of B and D. I can't be A or C because those are both positive, so I can cross those out. So now we're looking for B or D. Now, as we mentioned in the last time, in this case there's no parentheses, and so I do not have to change the sign. That's a big idea. It's abstract. When we will figure out why the parentheses we're making us change the sign later when we analyze that. But for now, I just want you guys to develop the instincts. And so we don't want to change it. We want to make sure that I'm looking for an equation with a constant term of negative 6. And I see this last number here is a negative 6. This one is a positive 6. And so that is not the one I want to pick. So we should have B. Okay, so let's try to develop this idea further. So now, take a look at the next example. Okay, where is our intercept? We see our intercept is right here at positive 8. So I want to choose one that has a constant term where we're looking for 8. And like I said, I'm just looking to teach you guys how to read these equations so that you can understand all the parts of them before we break things down and get more complex in this class. So the answer couldn't be A or C or even B because this one crosses at positive 8. So I'm looking for an equation with a term of positive 8. And so that would be D that I would like you to choose right here on this one. And we can see that we'll choose D. So now you should go ahead and try to pause this video and figure out what you think the answer is. And I'm hoping that you made a guess at least already. We know that our graph is crossing the y-axis at negative 4. So I'm looking for an equation that has a -4 at the end. And in this case, the only one that I see is B. So we'll go ahead and we should choose B as our answer. Take a look at this next one. So make a choice. And here you might say, okay, there's two possibilities. I know this is a -7 and that's a +3, but this graph crosses at -1. So what am I supposed to do in the case that I have these two possible answers? Well, now we'd have to figure out what the axis of symmetry is. And in this case, we had a formula. And we said that the axis of symmetry of a standard form equation, if you go look back at the assignment, we'll see we had this formula of -b over 2a. And so we want to get used to what all these numbers are. Again, a is the number in front of x squared. We'll consider b to be the number in front of x, the coefficient of the linear term, right? And c will be the constant value, which is the last number in this sequence. So we should test one of these. All right? We know it's not one of these, and we know it's not this one. And we could see on the graph that this axis of symmetry is right here, and so I know that that's x equals 1. So I'm trying to figure out whether or not one of these has that. Let's try this one right here. Let's try B and see what happens if we do this. Well, in this case, A is an invisible 1, and B is equal to 2. So what I teach you guys to do here to make sure we don't make too many mistakes is everywhere where we see a variable, we're going to put a blank parentheses. Okay? And now we plug in the values that we have. B, in this case, is 2. So let's go plug in 2 right here. And then here I see 2 times A, and A, like we said, is an invisible 1, so we'll put 1 right here. So now, if I multiply everything out, -2 means -2, and then 2 times 1 is just 2. So -2 divided by 2 makes -1. And so that tells me that this would have an axis of symmetry. Of course, as we were trying to say, the axis of symmetry is x equals -b over 2a. So we have an axis of symmetry of x equals 1. And this polynomial, when we worked with it, we see that we would have to get an axis of symmetry of -1, not +1. So that tells me that this can't be the answer, and the answer must be this one. So we would pick D in this case. We could try it again, and we could investigate whether or not we're going to get the right answer. So we might as well do that in this case, since we just started working with these forms. And so in this case, again, B is what I'm looking for, the number I'm going to plug in here. And if I try this one, we see a -2 this time. So we want to consider the sign of the number in front of it. This is a -2. And then again, in this case, A is also an invisible 1. So we'll put 1 here. And now we have to think about what -2 means. And -2 just makes a 2. So 2 times 1 is 2. And then we have 2 divided by 2 is 1. And so this tells me again that our axis of symmetry would be x equals 1 for this equation right here. And look what we got. We have an axis of symmetry of x equals 1. So that would be the way that we choose this one in the case that we have two possibilities and we can't make up our mind. So in that case, we would look at this formula for axis of symmetry. Okay, so that one was harder than the first two. Let's try this next one. Okay, maybe pause the video and try to make your choice. And I'm hoping you see that the answer is C, because this has a y-intercept of 3, and we see a +3 right here. Okay? So you might be thinking, why is this so easy? Why do we have to do this if this is so easy to see? Well, again, that's part of it, is we want to be able to tell what each form does just by looking at it, right? And so by looking at this form, we should be able to automatically know what the y-intercept is. Notice we don't know what the vertex is until we do some calculation. But at least by looking at this equation, we could tell where the y-intercept is. think about it, this point right here is the point x equals 0 and y equals 3. Okay, so this is saying that if I plug in 0 for x, then I'm going to get 3 out. And think about it, if I plug in a 0 here and a 0 there for x, 0 times 0 is 0, and 2 times 0 is 0, and 0 plus 3 makes 3. And so that is part of the reason why we can tell what the intercept is just by looking at it. Because if I plug in 0, that means by definition that I'll be on the y-axis, because x equals 1 is over here, x equals negative 1 is over there, but x equals 0 is the y-axis. The y-axis is also the line x equals 0. And likewise, the x-axis is the line y equals 0, right? This is the line y equals 1, right? This is the line y equals negative 1. So keep that in mind as we're graphing, that the coordinate plane is built a specific way. So now, take a choice what you think the answer is. I hope you made a choice, and let's take a look at the answer, and let's see that the answer is D here. Now you might be saying, well, hold on, there's two different ones that have a negative 6 at the end, right? I see that this axis of symmetry, this y-intercept is right here at negative 6. I see these two have a positive 6, so I can cross those out, but both of these have a negative 6, and so that tells me I got to think a little harder. But if you remember that we should be thinking about our happy and sad faces, and that was why I told you to think about that from the very beginning, because now we can expect what we should be looking for. We want our leading coefficient to be negative, and this one is negative, but this one is positive. So that means that B would give me a happy face, but this is a sad face. So this should not be the answer, and we should pick D. Okay? So multiple choice. These examples were meant to mainly test, do you understand where the y-intercept is? Do you get that idea? But now what we have is a more complicated idea of how to actually graph this equation instead of just going backwards. So let's jump down to the examples that actually have to do with graphing a standard form, and then we'll have wrapped up this little review session. So let's start with 38, and again, like we just said, we should be able to see this leading negative right here and realize, okay, this one's going to be a sad face, so we're going to have to think about that. And in math, it's always good to find patterns that can help us go faster. If we see they're always going to work, then we would want to use them, but we also want to be careful to be precise. So remember, we're looking for the vertex and the axis of symmetry. What I think some people might accidentally do is say, oh, look, I have this positive 1, and there's no parentheses, right? So we said we don't have to change the sign of any numbers when we don't have parentheses. And so now, maybe some of you guys are going to say, hey, look, that point is the vertex. But that would be wrong, because that's the y-intercept, not our vertex. So all we know is that our graph goes through this point, right? Maybe it goes like this. Maybe it goes like this. All we know is that it goes through there. We don't know that that's the vertex yet. I guess it's possible that the vertex is also the y-intercept, but it's also possible that it's not. So we want to make sure that we have the right idea. So we could plot that point if we wanted to, but in this case, I would kind of tell you not to do that, because who knows what's going to happen. Okay? Afterward, when we check our graph and draw something, if we don't get a y-intercept of positive 1, then that should definitely tell us that we did something wrong. So let's start with the way that we really do these. Every graph, we should realize that if we knew where the vertex was, we would be done with this problem really quickly, because we know our pattern of going over 1 and up 1 squared, or in the case where we have a negative like this, instead of going up, then we go down. Okay? But we have to know where the vertex is, of course, because like we said, that's where we kind of plant the seed and we do everything from there. from the vertex. But we don't know where the vertex is. So we're going to have to do a calculation. And then once we get it, it'll be the same as every other quadratic graph where the leading coefficient is 1. And at the end of this next part of the video, we'll talk about what we do when it's not just the 1 right here. So like we said, we're focusing on how to read these equations. That's all we really want to see, is that we have a x squared plus bx plus c, okay? And again, this is called standard form when we have no parentheses and when we're looking at a form like this. So everything is set up to look like it is in standard form. And so let's use our formula that we have for the axis of symmetry. And that formula is that x equals negative b over 2a. Okay, so that's our axis of symmetry. And it's also going to give us the x coordinate of the vertex. So let's do our calculation. As I told you, we want to copy the negative and then put a blank parentheses everywhere where we see our variables. So I'll copy the 2, but now that I see a variable, I'm going to put a blank parentheses. Now let's go plug our numbers in, okay? The value of b is 2, so we put a 2 here. The value of a is not 0. It's an invisible negative 1. When we see a negative, we should know that that's a negative 1. And so here, we're going to put negative 1. And then, let's be careful when we do our math right now. We know that negative 2 is just negative 2. But 2 times negative 1 is negative 2 again. So now we have a negative divided by a negative, and a negative divided by a negative makes a positive. And so we just have 1, right? We're dividing the same thing by itself. So that gives us positive 1. So now we know what the vertex is, at least in its x coordinate, and we know what our axis of symmetry is. Our axis of symmetry must be at positive 1. So I know this is my axis of symmetry. Now, to figure out this coordinate, we have to go plug in this number into our function. So I'm going to erase a little bit of work so we don't get too messy here. But you don't have to erase it on your paper. And we're going to go calculate f of 1. And when we calculate this value, this is going to tell us the y coordinate, and then we can get this finished up. So now, as I told you, we're going to substitute in a number. And as I told you before, we want to do this to avoid mistakes, because you're doing your hard work, you don't want to mess it up. So everywhere where we see a variable, we're going to write a blank parentheses, but we'll copy everything else. So I see an x, right? I see a negative x, so I put negative blank parentheses squared, and then I see plus, so I'm going to copy the plus. Then I see a 2, so I'll copy the 2. But then when I see an x again, I have to put a blank parentheses. And then now I see plus 1, so I'll put plus 1. So again, the blank parentheses go everywhere where we see x. And now I'll plug in this value of 1 into all those places. So 1 and 1 goes right here. Now let's do our calculation. And this is one that a lot of people have kind of messed up, because it can be a little confusing to figure out, what does this really mean right here? What does it mean that we have to do negative 1 squared? Well, if you remember the order of operations, we do, some people learn PEMDAS, right? Parentheses, exponent, multiplication, division, addition, subtraction. Other teachers teach GEMDAS, where we have grouping symbols, which might be like square roots or brackets or other kind of things. In this case, we're going to do the exponent first before we do anything else, multiplication. So consider, what does 1 squared mean? Like 1 squared, we have this negative, and 1 squared means 1 times 1. And 1 times 1 is 1. So because this negative is outside of the parentheses, we have to leave it there. So this is going to stay negative. And then we have 2 times 1, which is 2. And then we have 1 plus 1. So again, like I said, we have -1 plus 2, which is equal to 1. And then 1 plus 1 is equal to 2. So that is the y-coordinate of our vertex. So that tells me that to place the vertex, I have to go to the right 1 and then up 2. And that's my vertex point right there. And so now we'll follow the same pattern for quadratic growth, is what I'm calling it, is that if we go over 1, am I going to go up or down? We'll have to go down because, again, I see a negative right there. So that means if I go over 1, then I go down 1 squared, right? If I go over 2, then I go down 2 squared, and 2 squared means 2 times 2. So that's 4. So 1, 2, 3, 4. And then I'll put those points down where they go. Okay, again, if I go over 3, right, I have to go down 3 squared, and 3 squared is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can reflect all of our points across the axis, and then now we can connect these, okay? And we understand that that same pattern holds. That all we've done is basically move the vertex, and like we said, we should have a y-intercept of +1, and we'll see that, look, our graph crosses in the correct place. So it looks like our graph is correct now, and that was actually part of how you can check your mistakes, is if this doesn't work out right, then you at least know just by looking at it that something funny is going on. Okay, in this case, we got what we thought we would get, so we're doing okay. And we have a sad face because, again, we have a negative leading coefficient, so that means we should have our parabola that's open downward. So this problem would be done. Okay, again, we have our axis of symmetry, which is x equals 1. So let's move on to the next example. Okay, this time we have a positive leading coefficient. We have a +1 in front. It's invisible, like we said. So let's jump in and do this problem together. And I really recommend that the next problem that we do, that you actually try this on your own. So here we go. Let's get our axis of symmetry. Again, we know our vertex. Let me clean this up a little bit, because I think we're still working on this idea. We have to have a x squared plus bx plus c, yeah? So we know that we need to find our vertex, but we don't know where it is. Once we find the vertex, this is basically just a counting problem now that we know the pattern that we need to use. But the axis of symmetry is what we're looking for. So we know that our axis of symmetry is going to be the line x equals -b over 2a. So let's jump in here and let's make this work. Like I said, everywhere where we see a letter, let's put a blank parentheses. And then we'll add in our numbers right now. We can see that b is the coefficient of the linear term, so that's a 6, a +6. And the a is an invisible 1, +1, so we'll put a 1 right here. So now when we simplify this, we see that we get -6 over 2 times 1, which is 2, and that makes -3. So now that we have -3 right there, we know that this is also the x-coordinate of our vertex. So we have our axis of symmetry, and we got half of our vertex. We just don't know the y-coordinate. We need to get this number right here. And to get that number, we have to calculate f of -3. Okay, the other forms were much nicer than this because we didn't have to actually do that. But now we actually have to carry through this calculation. And like I said, everywhere where we see x, we just put a blank parentheses and we copy everything else. So now I go place in the value that I'm looking at, which is -3. So we're going to do -3 inside the parentheses and -3 inside the parentheses here. So again, on that last problem, the negative was outside of the parentheses. In this case, it's inside the parentheses. And so we know that this means -3 times -3. Okay? I probably wouldn't write that. You could if you wanted to, but I would probably just say that in my head and write it down. So we would say -3 times -3 is positive 9, right? Negative times a negative is a positive. And then we'd say, okay, well, what's 6 times -3? And that's -18. So we could write plus -18, which looks funny, but adding a negative just means subtract. So what I would really do would be to just write this first number down and say, okay, 6 times 3 is -18, and then I would just write -18, okay? But whatever way works for you. And then we have plus 3, so we just write that down. So now let's just finish this calculation. 9 minus 18 is -9, and we can't forget to add 3. So -9 plus 3 is -6. And so now we found the y coordinate of the vertex, okay? So we'll go put that down. I'm going to go left 3, and then I'm going to go down 6, and that's my vertex. I'm going to erase all these other lines, right, and leave the vertex where I know it should go. And now we consider, are we going up or down? Is it a happy face or a sad face? This should be a happy face, right? So we know I'm going up every time. So if I go over 1, I should go up 1 squared. And again, that's going to happen on both sides. If I go over 2 from the vertex, right, I'm going to go up 2 squared, which is 1, 2, 3, 4. And if I go over 3, like we said, if I go over 1, I go up 1 squared. If I go over 2, I go up 2 squared. If I go over 3, I go up 3 squared. And 3 squared is 9. And so we go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I put that point down, and I know I'll have the same thing on the other side of my axis of symmetry. Okay? Then we should, of course, connect all of these points with a smooth continuous curve. And then there we go. So it takes a little bit of patience and focus to get through these examples. That's why I left them for last. And these are the ones that, again, I took off of the exam, aside from one multiple choice problem. But I know that I'm going to need to teach this eventually. And so, you know, this video is here for those of you that are ready to attack this concept right now. Or maybe those of you that missed class and are reviewing this on your own. So I feel like at this point, it would be maybe a good time for you to pause and try to do this whole problem on your own, on your worksheet, or if you have some graph paper, some kind of way that you would like to try to figure this out and see if you're getting this process. And then by making a mistake, you'll actually learn something. So let's finish this process up. Pause the video, try it on your own. And I'm hoping you're back now and that you actually practiced. So let's take a look. We're going to find the vertex and the axis of symmetry. And so we're going to keep ourselves focused and understand, okay, I want to find the vertex, but I don't know where this is just by looking at this because this is standard form. So I know that I need to figure out my axis of symmetry. So we're going to have to use this formula that we have. We have x equals -b over 2a. And we practice copying the minus, putting a blank parentheses, copying the 2, putting a blank parentheses, and making sure we put the correct letter in the correct place. So again, we know that this is ax squared plus bx plus c. Okay, and we're going to copy the letters exactly as they appear. So b is represented by the number in front of x. And in this case, the number I see is a -8. So I'm going to copy a -8, exactly what I see. Then I look at the a, and in this case it's an invisible 1. So we should be used to that. In all of these examples, we'll have an invisible 1 until the case changes. So now we have -8. And what that means is basically, again, there's an invisible -1 right here, so we could think of that as -1 times -8, and that gives us positive 8. So like I always try to say, like when we were adding polynomials at the beginning of this year, I taught you that when you see negative outside of a parentheses, it means change the sign of the thing inside. So that means we're changing the negative 8 into a positive 8, okay? 2 times 1 is 2. And so we can do this calculation right here. 8 divided by 2 is 4. And so now I know I have to calculate f of 4. And I know that's my x-coordinate of the vertex. Let's go calculate this. We got 4 squared minus 8, and then I put a parentheses. I'm going to put the 4 inside of it, and then we got plus 15. Okay? And let's calculate. 4 squared means 4 times 4, that's 16. 8 times 4 is 32. And then we have to add 15. Okay, 16 minus 32 is negative 16. And then I have to add 15 to that. Negative 16 plus 15 is still negative 1. So now we know the y-coordinate of our vertex. So now I will put positive 4, negative 1, and now we can do our quadratic growth. We go over 1, up 1 squared, right? Over 1, up 1 squared from the vertex. Over 2, up 2 squared. 2 squared is 4, so 1, 2, 3, 4. Put that there. Same thing on the other side. Over 2, up 2 squared. So I'm right here. If I go over 3, I go up 3 squared, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Good, that's right here again. If I go over 3, I got to go up 9 squares, because 9 squares is 3 squared. So 9 squares takes me all the way up there. And now I just connect these with a smooth, continuous curve. Alright, so here we go. We have this process going. We have our graphed. We can see that our y-intercept is going to happen way up here somewhere, around 15. And so it looks like we're on the right track. Again, this is a happy face and everything. We see our axis of symmetry is right here at x equals 4. And that's what we want. So here we have this problem done correctly. So I would challenge you guys to do these problems on your own. Again, I've attached the answers to this worksheet, but you could pause this example and do it on your own. And you would want to get this answer that I'm going to click, so don't see it until you pause the video and try it on your own. And hopefully you tried it and you should have this. And if you don't know why you have this answer, then maybe try it again, try to look for your mistakes. Maybe you could show me what happened. You could shoot me a quick email and I could try to find the error in your mistake. But we learn a lot from our mistakes, so please go ahead and take a risk and go for it. Alright, well, I'll show you one more example. Okay, and actually it looks like this is the end of what I wanted to do today for our vertex, for a standard form. So we'll talk about leading coefficients that aren't 1 in a next video. We've covered this situation in class before, but I feel like it deserves its own video. So that'll be like part 4, but we'll wait for that another time, okay? So good luck, guys. I wish you guys luck in working on all this stuff. Again, this file is posted to Google Classroom, so please take a look and practice. Hopefully you learned something today. All right, good luck.